Hello, my name is Jack Lewnard. I'm a program director at ARPA-E, and I'd like to discuss REuse, a program to convert plastic and paper waste to high energy content liquids. I'd like to acknowledge Sade Ruffin, Tuxedo with Booz, Alan Hamilton, who's been working with me to develop this program. Because the REuse FOA is now live, questions should be directed to ARPA-E's contract office at the emails shown on the cover slide, and they've also posted answers to frequently asked questions at the link that's shown. REuse stands for Recycle Underutilized Solids to Energy, and the purpose of REuse is to investigate the economics for small regional facilities that could process waste in the 100 to 500 ton a day range. This is the scale of waste that's available from industrial sources, auto shredder waste, and other facilities such as material resource facilities where blue bin recycles are sent for sorting and aggregation. The assumption is that it's better to keep the processing facilities close to the sources of waste and ship the liquids versus shipping waste to large central processing plants. We need flexible and robust processes since the feed waste materials will vary over time, and of course the lowest cost feeds will have the widest specs. We're interested in novel chemistry equipment and process configurations in submissions to the REuse program. And we anticipate that the critical issue will be the low capital costs that are required at these small scales. We acknowledge that the chemistry for converting plastics and liquids is not going to be easy, but we think the bigger challenge will be keeping the CapEx in line with what's going to be economical given the small scale of these plants. The REuse scope, schedule, and budget is reviewed on this slide. Again, this is an exploratory program, and it really has two tasks which we envision will be coincidental. The first is the experimental phase, where we're looking to get conversion, yield curves, catalyst life, and other process information, looking at various processes that could be used to convert these materials. And the key to that will be a process flow diagram that helps inform what the overall process looks like. Coincident with that, we're looking to develop techno-economics for the inside battery limits, or the core technology or core unit operations for the process. And we're looking to get plus or minus 30% numbers, again, preliminary numbers. REuse has got a 6 to 18 month schedule, which is intentionally short. We're looking to get a quick turnaround on results and about a $4 million budget. The target feeds for REuse are shown in Section 2A of the FOA. And these numbers for the availability are based on EPA numbers from 2017 before exports bottomed out, which I'll be discussing in a little bit. The table shows that there's several kinds of plastic materials that we're interested in. The 1 to 7 polymers is typically seen on recyclable materials, rubber, and composites. And these composites are an unknown but ever-growing amount of the waste stream going into landfills. We're also interested in papers. And again, the sources for these materials are quite wide. There's MSW, municipal solid waste, the MRFs, or material resource facilities, where the blue bin recyclables are sent for aggregation. Auto shredders represent several million tons a year of both polymers and rubber and composite materials. And agriculture itself generates quite a bit of waste material. Paper is primarily found in MSW and collected at the MRFs. We mentioned the challenge of diverting plastics from landfill. The U.S. currently produces about 36 million tons a year of plastics, and the EPA typically records how much is recycled. However, the EPA's recycling category includes both domestic recycling, which you can see from the slide is less than 5% of material, and exports, which have historically dominated the recycling category. What's happened in recent years is that primarily Asian countries have begun restricting the amounts of waste plastics that they'll take in. And whereas MRFs historically sorted and were able to export about over 2 million tons of plastic materials, today those numbers have fallen significantly to the point where we're now landfilling about 2 million tons a year of plastics that were formerly sent to export. And so one of the targets for the reuse program is to recover those materials that are already being collected and sorted and being sent to landfill. It's a similar story for paper. The U.S. is the world's largest exporter of recycled fiber. We account for about 35% of the world's market. But because of import restrictions by other countries, our exports are actually down about 1.5 million tons a year in the last roughly 4 or 5 years. And so we have a fair amount of paper materials that are also being diverted to landfill. That, again, could be an excellent source of feed materials for the reuse program. Section 2B of the FOA discusses target products. And really here, the goal is to buy low, if you will, and sell high. So when you look at materials that are available for reuse processes, we talked about the polymers, and you'll see in the first table on this slide that PET bottles and HDPE bottles actually attract quite good pricing today in today's market, as does HDPE colored bottles and jars. Consequently, reuse is not particularly interested in projects that are focused solely on these materials because they already have active recycle markets. If you look at the other products that are available, say, for example, from MRFs, the 3 to 7 plastics, which are mixed plastics, you can see the pricing is quite low for those. Bulk rigids, which is a mixture of typically HDPE and polypropylene, again, fairly low pricing. The market for mixed paper is collapsed. Essentially, the MRFs are not getting any value. And anything that goes directly to landfills, which includes auto shredder waste, rejected bales from the MRFs, agricultural films that are thrown into the waste disposal systems, all of these materials basically have a negative value of about $55 a ton in the U.S. That's our average cost to landfill. So those are the feed materials, and if you look at what it's possible to convert those into using reuse type processes, you'll see that the light gases, the light hydrocarbon gases, ethane, methane, propane, while having a positive value, those values are generally fairly low. As you get into hydrocarbons that are, say, in the C5 to C20 range, those products can be actually quite attractive as in-stream markets. When you get into the bottom of the barrel, things like solids such as char, you'll see that those have very low value. An interesting stream to consider targeting is the BTX, benzene toluene xylene streams, which have extremely favorable pricing given their use as chemical feedstocks. Section 2C of the FOA discusses the target processes, and the table shown here is reproduced from the FOA. Now, this table is not meant to be exclusive in any way or exclude other processes that aren't shown. It's really meant to organize the discussion in this part of the FOA. And what we've done is ranked the processes that have traditionally been used or considered being used for these types of materials based on the most reducing conditions to the most oxidizing conditions. The most reducing conditions include things like hydrotreating, hydrocracking, where catalysts are used with hydrogen to break carbon-carbon bonds. The same carbon-carbon bond cracking can be done thermally. Again, this is a technology that's been long practiced in the refining industry. When we get into the area of torrefaction, pyrolysis, and solvolysis, the reuse program is discouraging applications in those areas, not because of the legitimacy of the technologies, but rather because there's already been extensive work done by others, particularly in the Department of Energy, and there's existing FOAs that are out there to address those topics. So unless there's something very exceptional about the process that's being proposed, we're discouraging applications in those technology areas. Autothermal pyrolysis and gasification brings in the use of oxygen or air to provide the temperature that's needed to crack the carbon-carbon bonds. Fluid cracking is a very interesting technology, again, coming out of the refining industry, which is essentially a two-stage endothermic cracking followed by oxidation with air to generate the heat that's required for reaction. And then there's a number of novel oxidative processes that have been discussed in the literature, for example, using nitric acid to depolymerize composite materials. There's been a lot of work in this area in the past, going back to the 70s and in some cases even earlier, that was motivated by the energy crisis during that time. So, for example, a wide number of studies have looked at paper, plastics in singular form or in combinations, including with coal. There's been a number of researchers who have looked at mixing plastics in with refining streams. And so there's an extensive literature. And one of the resources that we're making available is a background information document that summarizes some of the literature for these technologies to make people familiar with some of these processes. But again, there's a wide spectrum of chemistries that have been demonstrated. And to the point that I made earlier in the presentation, we believe that the chemistry can be made to work if you throw enough money and resources at it. The question for reuse is, can you make these chemistries work at this scale at a price point that the market can afford? I hope you found this a useful introduction to the reuse program. More information is available on the ARPA-E website. The FOA funding opportunity announcement for both the I'll call it regular version and the SBIR STTR research reuse call for proposals is in the link that's shown on this slide. Further information is available from a blog interview and the background information document that I mentioned before, which goes into further details about the feeds, the products, and the processes. And again, because the reuse FOA is now live, questions should be directed to the ARPA-E Contracts Office, and you can also check their frequently asked questions answered that they've posted on the link that's shown. I'd like to thank you for your time and attention and look forward to working with you on this program. Thank you very much.